All right, let's dive in. Today we're going to tackle something that sounds super technical, temporal query answering in description logic. But stick with me, because what this is really about is solving a problem we all bump into every single day. And that's the big question right there. I mean, think about it. Just about all the data in our world is constantly on the move. You've got stock prices, social media feeds, server statuses, even the inventory of an online store. So how on earth do you ask a question about what was true in the past when the present looks totally different? Okay, here's a simple example. A system admin doesn't just need to know if a server is online right now, they might need to know if it was online at 3 a.m. yesterday. The system has to be able to kind of time travel, right? To query a state of the world that just doesn't exist anymore. That one little word, yesterday, completely changes the game. And it's not just a tech thing, either. A business manager needs to know what was in stock last week so they can figure out what to order for next week. So you see the pattern here, right? We're trying to ask questions about data that has this temporal dimension. It's like every piece of information has an expiration date on how true it is. So, how do we actually build a system that can do this? How do we teach a computer to understand the past? Well, it all starts with our first key ingredient, a special kind of logic that was built specifically to handle time. And that brings us to temporal logic. Now, this isn't your standard run-of-the-mill logic. Its whole reason for existing is to let us formally reason about ideas like eventually, or always, or until, or even previously. It gives us a really precise, almost mathematical language to talk about time itself inside systems that are always changing. And listen, this is not just some abstract theory. Temporal logic is an absolute workhorse in computer science. It's used to make sure the really complex systems we all depend on, I'm talking about our operating systems, the protocols that make the internet work, are all behaving correctly over time. It gives us a way to mathematically prove that something bad will never happen or that something good will eventually happen. It's a seriously powerful tool. But, just having a language for time isn't quite enough. It's like having a perfect clock, but no world to tell the time in. We also need a way to describe the world that's actually changing, which brings us to our second and just as crucial ingredient. And that would be description logic. So if temporal logic gives us the when, description logic gives us the what. It's a formal way to structure all our knowledge. We can define concepts like product or server, and then create relationships between them, like is in stock or is online. Think of it as creating a super detailed, logical blueprint for all our data. And just like temporal logic, this isn't some brand new idea. It's built on a really solid academic foundation. We're talking decades of research into how we can represent knowledge so that it's easy for us humans to get, but also rigorously logical so computers can process it. It's a really well-understood framework for creating meaning. Okay, so we have our two main ingredients. One is for understanding time, and the other is for understanding our data. I think you can probably see where this is all going. It's time for the aha moment. Let's see what happens when we put them together. So, on the one hand, we take this incredible tool for reasoning about how things happen over time. The sequence of events, the duration, the changes. This is our engine for understanding the when of it all. And now for the magic. We don't just put these two things next to each other. No, we actually fuse them. We're about to weave the logic of time right into the very fabric of our knowledge. And we combine that with our solid blueprint for the world. The what's, all the concepts, the categories, the relationships. By itself, it's just a snapshot, a single picture. But what if we could make that picture come alive and move through time? Well, the result of putting these two together is a system that can do something pretty remarkable. We've basically given our data a memory. We've unlocked its fourth dimension, time. And that leads to this phrase from the research that just perfectly nails it. We are navigating data in time. We're not just asking a question to a flat, static database anymore. We can literally travel through our data's history and ask complex questions about how the world used to be. It's a complete, four-dimensional picture of our information. So this is all really cool, right? We've mashed up these two powerful logics to create this incredible new capability. But let's get real for a second. What does this mean in the real world? So what? Well, it matters because people are actually building this stuff right now. They're creating specific systems, like one based on something called DL-Lite, which is basically a nimble, lightweight version of description logic that's designed to be super efficient.
The whole goal is to create practical tools that can handle huge, real-world knowledge bases that are always changing without everything just grinding to a halt.
So here's the bottom line. By combining these logics, we get the power to build truly smarter systems. I'm talking about systems that get that data isn't static, it's a story. Systems that can answer our questions about the past with real certainty. And systems that can correctly handle time, which, let's face it, is fundamental to pretty much any data set that actually matters.
And that kind of leaves us with one last really fascinating thought. So much of this work is about understanding and asking questions about the past. But once a system truly gets the patterns of how things change over time, it just opens up a whole new world. What happens when we turn that incredible analytical power away from the past and start pointing it toward the future? Thanks for joining us for this explainer.